In this video lecture, we will see that why transformer cannot work on DC and what will happen if accidentally we provide DC to the primary winding of the transformer. So to understand this, first we will see that how transformer works. Transformer works on Faraday's law of electromagnetic induction. This law states that whenever there is a relative motion between conductor and flux, an EMF is induced across the terminals of the conductor, and the equation of the EMF is given by E is equal to minus N d phi by dt. So when we provide alternating supply to the primary winding of the transformer, this alternating voltage produces the alternating current in the binding. Due to this alternating current, uh, a flux is produced in the core of the transformer. This flux is also of varying nature because flux depends on current, and if current will change, then flux will also change. So this varying flux produces the EMF in the primary and secondary winding by Faraday's law of electromagnetic induction. Due to this induced EMF in secondary winding, current starts to flow in secondary winding and we get power in the load which is connected at the secondary terminals of the transformer. So in this way transformer works. So in this section we will see that what will happen if DC supply is provided accidentally to the transformer. So for this we can refer this diagram here. We have a core and two bindings, primary and secondary. The primary binding resistance is R1 and reactance is X1, and secondary binding resistance is R2 and reactance is X2. When we provide the voltage V1, then current start to flow, and if the supply is of DC nature, then this will produce a constant current in the primary winding. This constant current will induce a constant flux in the core of the transformer. This constant flux will not be able to induce EMF in the primary and secondary winding because E is equal to minus N d phi by dt. So here the change of flux is zero. So EMF induced will also be zero. Here at the primary side, the equation is V1 is equal to E1 plus I1 R1 plus JX1 by KVL law, because the applied voltage is equal to the voltage drop across the binding plus EMF induced. So if E1 and E2 will be 0, so we will not be able to get power at the secondary side. Also here, if E1 will be 0, then for same supply voltage, current I1 will be very high because this binding resistance and reactances are constant in nature because bindings are fixed. So for same voltage, E1 will be 0 and high current will start to flow to compensate this. So this high current may damage the primary winding of the transformer. So consequently, we can say that if we provide DC supply to the transformer, we will not get power at the secondary side because E2 will be 0, and also the primary winding may get burned because a high amount of primary current will start to flow in the primary winding. So this is all about that what will happen if DC supply is provided to the transformer. Thank you very much.